Okay, so what we're going to be looking at, guys, is we are going to be looking at equations in the form y equals a times b to the x power. And we absolutely care what this a value is, and we absolutely care what this b value is, okay? Now, your exponential functions, depending on what those values could look like, are going to look like one of the four scenarios we see down below. They're either going to look like that blue one on the left, that blue one on the right, that red one on the left, or that red one on the right. Now, I'm going to tell you how they could look like these, okay? Your a value will determine whether you're above the x-axis or below the x-axis. So check it out. If your a value is positive, those are your two blue graphs that you see. And those graphs are above or below the x-axis, guys. Are the blue graphs above or below the x-axis? Above. Now, these values for your y values will get very, very close to 0, but they'll never actually touch 0. Same over here. Your y values will get very, very close to 0, but never actually touch. Now, are these graphs straight lines anymore? No, exponential functions do have a curve. Do you guys see that? Now, when your a value is smaller than 0, aka it's what sign? Negative, right? So when a is less than 0, where are the red graphs? Below the x-axis. Very good. Below 0. So highlight that. When a values are less than 0, you're existing below. Now, the curves happen based on your b values. So I need you guys to take a second and highlight the fact that b is greater than 1 in the examples on the left, and b is between 0 and 1 in the examples on the right. Now, when b is larger than 1, for example, 2, 7, 8, 4, okay? Those are all values bigger than 1. Your graph, as your x values increase, as you go from left to right, what's happening to your y values? They're going up or they're going down, right? They're either getting bigger in the positive direction or they're still getting bigger, but in the negative direction. Do you guys see that? They're separating from 0. Now, if your b value is between 0 and 1, as we move left to right, where are our y values approaching? The origin, 0, okay? They're approaching the x-axis. Now, something that you guys need to know for exponential functions, these guys never actually touch 0, okay? They get really, 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 really close, but they never actually hit 0, okay? For exponential functions. This is very, very important, okay? Now, how do they get a graph that looks like this? We're going to plug in and see how they get a graph that looks like this, okay? Exponentially, how we get a graph like this. So, so technically, they're continuing in both directions, actually, Matthew, okay? The red arrowhead is currently covering the blue one, okay? But they do extend in both directions in the x direction, okay? Good question. Any other questions before I move on to graphing one? Okay, this is brand new stuff, guys, okay? So if you're a little bit confused, that's all right. Just follow along as we do these next few examples. Which of these had an a value larger than 0 and a b value larger than 1? The first one, because the b values are larger than 1, and the blue or the red graph? The blue. So when we're done, we should get an exponential function that looks like that. Let's test it, okay? We're going to plug in 5 points, and we're going to see where those points are on our graph, okay? This one right here, right? So when we're done, let's make sure that it looks like this red graph on the bottom, okay? Example, okay? I want us writing down the a and the b values when we're graphing these, and then at the very end, we're going to describe the domain and the range. Matthew.
How do you know what side it's going to? Because on the one on the left is going to...
All right, let's see our first example. We have f of x equals 4 times 2 to the x power. What is my a value in this scenario? My a is equal to 4. That is the number in front of your base. That's not actually part of your base. Do you guys see that? So a is 4. What is my b value? 2. So now, just with my a and my b value, I can determine what this is going to look like. You care whether your a is bigger than 0 or smaller than 0, whether it's positive or negative. What is a? It's bigger than 0. 4 is bigger than 0. And then your b value is larger than 1 or between 0 and 1? B is larger than 1. So check this out. Go back to the very first 4 graphs that they did. So let's plug in -2. So we're going to evaluate our function when x is -2. So f of -2 equals 4 times 2 to the -2 power. What did I do there? I just plugged in an x value of -2. Okay, these are the numbers we're going to use for the entire lesson. -2, -1, 0, 1, and 2.
Can I go to the bathroom?
Okay, Mia, what's up?
Would you always plug in the x values to your exponent too?
Mm-hmm, yep. So when I plug in -2 here, what do I do? What do I do to evaluate this? I multiply what? Don't multiply -2 by anything. -2 is an exponent. What do I do with negative exponents, guys? You flip it. So let's flip it. It's going to be 4 times, what's 2 flipped? 1/2. And now it's to what power? It's no longer a negative exponent. It's a +2. Mia?
Why did you flip it?
Because it was a negative exponent. Anytime you have a negative exponent, you flip your base. Okay? So now, what's 1/2 to the second power? David, what's up?
How do we flip the base?
Anytime you have a negative exponent, you've got to flip your base.
Oh, you flipped the base, not the exponent?
Not the exponent.
Okay.
Okay? The exponent changes from negative to positive when you flip it. Okay? But remember, a negative exponent indicates you need to use the reciprocal. Okay? Good questions. Any other questions before I move on? Okay, what does 1/2 to the second power mean?
1.
It's not 1. That would be 2 times 1/2. Karen? It would be 4 times 1/2 times 1/2, right? Because squaring something says you multiply it by itself, correct? Are you guys in agreement? What is 1/2 times 1/2? It's 1/4. So do you guys agree this is 4 times 1/4? What's 4 times 1/4? Mia?
Oh, wait, I don't.
What's 4 times 1/4? Very good, Salucci. It's 1. Because it's 4/4, which is 1. So what was my x value here? -2. And what was my y value? 1. Segi, did you say 1? Whoops, my bad. So my first point is at -2, 1. Mia, what's up?
How did you get multiplied 1/2 by 1/2?
Because that's what it means to square something, right? So if you raise 1/2 to the second power, it's saying that number, that base, times that base again. If it was to the third power, it would be that base times that base times that base, right? So it depends on what power it is, okay?
Just don't touch the 4?
No, because the 4 is not part of the base, okay? It just stays on the outside. Yes, Andrea? So your a value, always care whether it's positive or negative. Okay, so compare it to 0. And your b value, compare it to 1. Mm-hmm. And it's always a positive or negative, b compared to 1. Okay? Good questions. Any other questions, guys? Yes, Alonzo. Okay, so any number squared, right? Caitlin, what is 2 squared? It's 2 times 2. That tells you how many times you multiply it. What is 2 cubed? 2 times 2 times 2. So when we have a fraction, right, like 1/2, and we're cubing it, you're taking that fraction and you're multiplying it by itself that many times. So this would be 1/2 times 1/2 times 1/2. Okay? Does that make more sense? Okay, excellent. Mia, does that work for you? Okay. All right. Let's do -1. So f of -1 equals what?
Equals 2.
4 times 2.
Exponent is
Exponent is -1. What do I do with negative exponents, Kyra?
So you gotta flip the 2.
Very good. So what is it going to be?
So 4 times 1 over 2. And you don't need, well, it would be 1.
It would
You
be
don't
1.
need to put it.
You don't need to put it. Very good. Because anything to the first power is just itself. What's 4 times a half? It's 2. So this is 4 over 2, which is 2. Are we seeing how this works?
Wait, I don't get, how do you get 4 over 2?
Well, what's 4 as a fraction?
Oh, 4 over 1.
4 over 1. What's 4 over 1 times 1 over 2?
4 over 2.
4 over 2.
Why didn't you put 4
I mean, negative 1 comes
over
from
2 in the first one?
Because it was 4
Oh,
over
yes.
4, right? Which would
Okay,
become 1.
okay, yeah.
Okay?
-2, -1.
-1, 2. Very good, David. Okay, let's graph it. -1, 2. Okay, so we have those 2 points. It could be a straight line if we did it now, but should it be a straight line for an exponential function? No, we should have a curve. So by our third point, we should see which way this is going to curve, okay? Let's try 0. So f of 0 equals, we're going to do 4 times 2 to the 0 power. AJ, what's anything to the 0 power? So this whole thing becomes 1? Good, just the 2 to the 0. So it's 4 times 1. What's 4 times 1, guys? 4. So my next point is what? 0, 4. Check it out when we plug in 0, 4. Oh, look at that. Do you see how it's curving now?
Yeah.
It's getting very, 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 very quickly. It's increasing its y values, okay? Exponentially increasing its y values, okay? Hence the exponential function. All right, let's do another one. Let's do 1, f of 1. So when I plug in 1, I'm going to get 4 times 2 to the first power. Colin, evaluate that for me, please.
F of 1 equals 8.
Very good, because it's 4 times just a regular 2, which is 8. Very good, Colin. So what is that point, Colin?
1,
1,8. Excellent. So 1,8, let's plug it in. It's going to be right here. Do you guys see the curve now? How it's going super, super high, really, really fast? And then let's do the last one. Miss Gagne, I'm going to have you walk me through the last one.
Okay. So first you write down f of 2,
Mm-hmm.
which equals 4 times 2 to the second power.
Excellent.
2 to the second power is 4. So 4 times 4 equals 16.
Good.
So the answer is 2, 16.
The next point is 2,16. That was excellently done. Very good. 2,16. Guys, does that fit? No, don't stress, okay? 16 would be somewhere very, very high off of our graph, but we just verified that we did everything the right way, right? Because another point should exist somewhere way up there, right? Now we're going to roughly sketch, it doesn't have to be perfect, your graph. Remember, your values never hit what y value? 0. So it's going to get very, very close to the x-axis, but it'll never actually touch.
I can't.
Go back to the graph that we circled. Does it not look very similar to that blue graph that we circled? Okay. You can get an idea just based on the a value and the b value what your graph is going to look like. AJ.
So when you're drawing the line, you don't need to like put it, just put it close to 0. You don't need to put it.
Don't actually have it touch the 0. Don't have it cross. Because if you drew it where it crosses, this would be wrong, AJ. Okay? Just have it get really, really close. If you want to have it merge, I've seen that before, that's fine as well. Okay? But technically, it's never actually touching 0. Okay? All right, and then lastly, guys, we're going to talk about the domain and the range. Our favorite. Okay, so domain is in regards to what variable? X. What are my x values here? Is there any restriction on my x values? No. When there's no restriction, what do I say? All real numbers, ARN, okay? And if you forgot that one, label it all real numbers. Okay? There's no restriction on what you can pick for x. Caitlin. So like, do you agree that my x values, I could plug in negative infinity for x, and my graph would continue on to negative infinity in the left-hand direction? I could also plug in positive infinity, right? My x values are constantly increasing. This is going to go on forever, correct? Now, for y, the y values will always get higher, right? But never drop below what value? 0. So check this out. Your y values are being compared to 0. But these y values are all larger or smaller than 0. So what inequality would satisfy that? Greater than 0. Do not include 0. Brayden? Yes, you may.
Wait, I don't get it. I don't understand how y is greater than 0.
Why y has to be bigger than 0?
Yeah.
All right, Mia, look at all these points. What's the y value here, Mia? The y value.
8.
What's the y value here?
4.
4, 2, and 1, right? They're getting smaller, but they'll never touch what? 0. So my y values are all bigger than 0. Does that make more sense? Okay. Yes, Michael. Yes, you may. All right, let's do another one. Let's do this one, okay? Let's first identify our a value and our b value. What's a? -2. What's b? 4. All right. I need to know whether my a value was positive or negative. Was it bigger than 0 or less than 0? Less than 0. And my b value? Bigger than 1 or smaller than 1? Bigger than 1. So watch. Go back up to your graphs, your first 4 examples. Which one had an a value less than 0 but a b value bigger than 1? All right, let's plug in. We're going to do f of -2 equals -2 times 4 to the -2 power. I just plugged in -2 for x. What do I do? Okay, so this is going to be -2 times 1/4, still to the second power. So it's 1/4 times 1/4, right? What's 1/4 times 1/4? It's not 2/4. It's not 1/4. It's 1/16. So this is 2 times 1/16. What's 2 times 1/16?
It's a negative.
It's 2/16. Wait, it is a negative, isn't it?
Yeah.
So it's going to be -2/16. Can we simplify -2/16?
Yes.
What is it?
Negative 1 over
-1/8. So my x value is what? -2. My y value was? -1/8. Let's go ahead and graph that. -2, comma, -1/8. How do I graph -2, -1/8? I go to -2, but then what?
It's gonna be like closer to -2.
Closer to -2?
Yeah.
So like close to here?
And,
You said -2, right?
No.
No. Where does it go? Yeah?
Just like a little bit off of the line.
Really close to 0, right? Because -1/8 you barely have. You're going down 1/8 of a unit. And 1/8 of a unit, so take this unit, this whole length, divide it into 8 pieces, and you're only going down 1/8 of that piece, okay? So you're going to get a dot that's really, really close to 0, okay? So -2, comma, -1/8. All right, let's do it again. What? I just graphed a point. This one, -2, comma, -1/8. So David, -1/8 is like a very, very small piece of 1, right? So go down -1/8 and you're really close to 0 still. You're barely going down anything, but you still move to the left 2 units. Okay? All right, let's try another one. Let's try -1. So f of -1 equals negative 2 times 4, and then to the negative first power. What do I do? Natalie?
First, you change the exponent to be a positive one.
Good.
So
And
the equation is going to change to negative 2 times 1 over 4, and then that's it because you don't put the 1.
very good. And what is negative 2 times a fourth? Negative 2 over 4. Can that simplify? It's negative a half. So my next point, Addison, is what?
Negative 2 and negative 1.
Close. What did we plug in for x?
Oh, negative 1.
Ah, negative 1. Okay, so negative 1 comma negative 1 half. Very good. All right, where's negative 1, negative 1 half? Someone describe negative 1, negative 1 half to me. Natalie?
You go left 1,
Mm-hmm.
and then half a cube down.
Good. Half of a unit down, so it's somewhere in between there. David, do you see how this one's negative 1 and then negative a half is down half of a unit versus an eighth of a unit, which was much closer to 0? Okay. Next one, we plug in what for x? So f of 0 equals negative 2 times 4 to the 0, which is negative 2 times, what's 4 to the 0? So it's negative 2. Negative 2 times 1 is negative 2. So my next point is 0, comma, negative 2. Plot it, and we got our third point. Okay. You guys look very tired to me, so I'm going to kick you into gear. Do the next two on the chart by yourself. Plot them and see what it looks like, and then try to find the domain and the range. We'll compare at the end. Go. F of 1 should have been negative 8. 1 comma negative 8. F of 2 should have been negative 16. Nope. Negative 32. So it should have been 2 comma negative 32. And then 1 comma negative 8. 2 comma negative 32 is going to be too large. Okay, how many of us got an exponential function that looked like that when we graphed it? Excellent. Okay. Now, we have to define what the domain and the range were. Did anyone get an idea for the domain? AJ? Very good. It's all real numbers. Guys, for almost all exponential function, it's going to be all real numbers, okay? It's fair to assume that if I ask this, domain putting all real numbers is like 99 times out of 100, it's going to be right. Because there's no restriction on our x values. You can plug in whatever x value you want. Now, the range is not so trivial. Yep. Y is now less than 0 because the y values are all negative. Mia, do you see that? Because you asked me about that the last time.
Yeah.
Does that make sense?
How did you get all real numbers?
All real numbers?
Yeah.
So do you see how my x values continue on to the left forever? And they continue on to the right forever? Think of this x-axis as a number line, right? Wouldn't you say that we're shading both sides? So my x values are from negative infinity to positive infinity, which means that they're all the real numbers in between those two. Okay? All right. The next example is we're going to do one where we have a fraction as our b value. Okay? So please, guys, up at the top where it says graphing, highlight that b values are going to be between 0 and 1. All right, let's check it out. So we still have to identify our A and our B, and then we're going to graph it. So what's my A value here? It's negative 1. Okay. Is that bigger than or less than 0? Go ahead, McCarvin. And then my B value is what? It's 1 over 2. Now, remember, b values, we don't care whether they're positive and negative. They'll almost always be positive. We care whether it's bigger or smaller than 1.
Do I have to write this down and
Yeah.
The A.
Yeah.
Okay.
Because isn't there technically a 1 here, Miss Alonzo? Remember, if there is no number in front of the parentheses, there's always a 1 there, okay? All right, so my b value is 1/2, correct? So that is between 0 and 1, correct? So my b value is between 0 and 1. So watch, guys. As my x values increase, my y values are actually going to approach 0, okay? So this one's going to look like the flip, the reverse of what we just did, okay? All right, let's start by plugging in values. So we're going to plug in -2. F of -2 equals negative, and we're taking 1/2, and we're raising it to the -2 power. Who feels comfortable with these negative exponents now and wants to take a shot at this one? Addison?
I changed it to -1 times 2 over 1, and then changed the 2 to a +2.
Good. So you wrote it like that?
Yeah.
Excellent. Addison, why did you flip the 1/2?
Because the exponent was negative.
Good. Anytime we have a negative exponent, guys, flip your base. What is 1/2 flipped? 2 over 1, or just 2. What's 2 squared, guys?
-4.
It would be 4. And remember, it has a negative in front, so it's going to be -4. So f of -2 was equal to -4. What's my point, Addison?
-2, -4.
Excellent. -2, comma, -4. So we go to -2, we go down to -4. Here's our first point. All right, let's do -1. F of -1 equals -1/2 to the -1st power. Salucci, can you help me with this one?
-2 in the parentheses to the power of 1.
Very good. What does this give me?
2.
No,
Negative.
-2. Very good. Okay, so f of -1 is -2. Alfonso, what point is that? Which point should I put on this part of my graph?
-1.
-1, comma.
Comma -2.
Very good. So we go to -1, we go down to -2. Here's our second point. You guys, same thing as last time. You guys fill in the rest. Let's compare at the end. Go. Okay, the answers are on the board. Go ahead and compare with your group. Compare with the board. Talk about it. Go. 5, 4, 3, 2, and 1. So guys, graphing those fractions, I've gotten that question a lot. How do we graph -1/2? How do we graph -1/4? Remember, -1/2 is just right in the middle between 0 and -1 for your y values. So you see how this is right in the middle between 0 and -1? -1/4 should be closer to 0 or closer to -1? Closer to 0. Because having -1/4 is just barely having less than 0, right? -3/4 will be closer to -1 because it's a larger negative number, okay? And -1/2 is going to be somewhere right in the middle. So this is what your graph should have looked like. Your domain should have been all real numbers, and your y values for your range should have been less than 0. Any other questions on this example? Okay, guys. You guys have enough to where B, you guys can totally do on your own, okay? So I'm not going to do B with you, okay? But you guys can totally do it on your own. If you were to do this problem, okay, you're going to get a graph that starts with very high y values and approaches 0 as you go increase your x values, okay? Your domain for this one would also be all real numbers, and your range would be y is greater than 0. Okay? The last piece of this lesson is we're jumping back into transformations. Okay?
Oh, no.
Oh,
no,
yes.
No. Oh, my God. I failed that test.
So, transformations. Now, those of you that are like, I did not do well here, that's okay. We're going to get better. Okay? I need you guys to highlight this formula.
What? I don't remember. Okay. I thought that we were the easiest
So, this is a new formula that we have not touched before, okay?
What's H?
Now, do you guys remember in the past when we were talking about transformations and there was an opposite world and a real world? Okay. Your new opposite world is anything in your exponent. So put parentheses around this x minus h and label this your opposite world.
X minus h is the whole exponent. How does that even work?
Okay? Now, your k is not part of opposite world. Where is it?
Outside.
In the real world, okay? Outside. What about your a? Real world. B is just your base. B is the only value that is not going to contribute to your transformations, okay? Because it's part of your base, all right? Now, let's take these one step at a time. We're going to do two together, and then I'm going to let you guys do the third one on your own, okay?
Wait, what are we, I thought we were doing the thing.
Okay.
I thought we were back.
Take a look at this example. Example 5a. We are not going to graph these. We're just going to describe the transformations.
Oh, fun.
So, start it one piece at a time. You guys, I don't really like our attitudes right now. We're starting to give up and we haven't even started. How do you know you can't do this?
It's usually
Okay? How do you know you can't do this? You haven't even begun. Okay, what if I told... It's not that hard. It's easy. Let's do it. So, take a look at the 4. What is the 4 doing? What operation is happening with the 4? Multiplication. Do you guys remember what transformations involve multiplication? Stretches and shrinks. So, this 4, remember, is it part of opposite world? No, that means it's what kind of transformation? Vertical or horizontal?
Wait.
Vertical. Okay. Anything in opposite world is going to be horizontal. Anything outside is going to be vertical. So it's vertical. Is it a stretch or a shrink, though?
It's a stretch. Because
Why?
It's greater than 1.
Very good. It's a stretch.
Yeah, how do you remember?
Because it's larger than 1.
I had to
So
ask
it's a
you
stretch
multiple
by
times.
4. If you need to put a note to yourself, 4 is bigger than 1, therefore it's a stretch. Okay? Now, does the 2 contribute to your transformations?
Yeah.
No, because it's part of the base. Okay? So then we move on to the x minus 3. Highlight the minus 3. What operation am I saying when I say minus? Subtraction. Subtraction involves what transformations?
Oh.
Not shrinks anymore.
The reflection, right?
Not the reflections. Translations or shifts, okay? So you can say it's a shift. Now, this shift is in what world? So it must be a vertical or horizontal one? Horizontal. And it's to the right 3. Why is it to the right 3?
Because the 3. I remember that.
Because it's minus 3. But doesn't minus 3 usually move us to the left?
It's an opposite world.
It's an opposite world.
I thought parentheses around.
Now I get it.
Correct. So, guys, there's not going to be parentheses around it. Are you allowed to draw your own parentheses around the exponent?
Yes.
Sure thing. Okay, you can totally put parentheses around that. All right. Now, the plus 2. Highlight the plus 2. What operation is plus 2?
Be optimistic.
What operation is plus 2? Addition.
Translation.
So when it's addition, it's going to be a translation. Is this vertical or horizontal?
Vertical.
Vertical. Translation.
Is it because it's positive?
Now, if you're vertically translating something positively, where are we moving?
To the right twice.
No, right is horizontal.
What?
What's vertical? Up 2.
Up 2.
You're so smart, bro.
Vertical. If it's not an opposite world, it's always vertical. Okay, think about it like this, Miss Alonzo. If it's not next to your x, it's going to be vertical. Okay? Okay, so let's do the same thing with the next example. All right, so we're taking a look at y equals -2, base of 3, raised to the x plus 2 exponent, and then minus 1. Take it one step at a time. Guys, this negative is its own transformation. Remember, a negative outside your parentheses, that's going to be a vertical. Reflection. And if you're vertically reflecting something up and down, it would be over the x-axis. All right, and then the second one, we have this 2. Remember, it's being multiplied by your function, so it's going to be a vertical stretch by 2. The reason it's a stretch is because it is a number that's greater than 1. It's being multiplied, and it's outside opposite world, which is in your exponent. So it is going to be vertical. And then we have the plus 2 in opposite world. So it's horizontal. Remember, opposite world for exponential function is anything part of your exponent. It's horizontal. It's a translation, aka a shift. You can put either of those words, shift. And then lastly, you have to say it's to the left. The reason it's to the left is because it's opposite world, so that plus actually means to the left. And then the last one is this -1. It's a vertical shift down 1. And I believe the last example I want to do here is this one. There's actually only one transformation going on. It's this +3. It's a vertical shift up 3. That's it. Okay. And then